So now, of course, we need an application, and the best application is a rocket. Of course, we got to shoot a rocket here. Projectile height. It's fired. The rocket's fired upward. Its height in feet, h, is above the ground. T seconds after it is fired is given by this formula. H equals negative 16 t squared plus 128. It's supposed to be t plus 2048. Okay. Now again, it's a negative parabola. In other words, you're shooting a rocket up and then it's coming back down. Okay. So that's the situation here. So we're supposed to find the maximum height. Now maximum height, of course, is going to be right here at the vertex. And then how long it takes until it hits the ground. Okay. Well, to find the maximum height, we just have to find the vertex. And we've got a good tool to figure out what the vertex is. We've got the formula h equals negative b over 2a. If we figure out what the h is, then we can just plug it in and find k. So bottom line, we've got to find the vertex. So I take my negative 128 over 2 times my negative 16 and plug that into my calculator. And I should end up with 4. And then what I'm supposed to do is take my 4 and plug it back up into the equation to figure out what the k value will be. So, and by the way, this might be confusing. This h is not the same as this h. These are not the same h's. H up here is technically and that's really weird, that's standing for height. This h is my hk for a vertex. So let me just replace this h down here with x. It's the x value of my vertex. So when I plug this back in, or I guess you could even say it's the t, because technically in this formula we've got t's. So we'll put a t here, sorry. T is equal to 4. Okay, so I take my 4 and plug it in for t, and that's going to give me my height, okay, my y value of the vertex. So I'm going to get my height is equal to negative 16 times 4 squared plus 128 times 4 plus 2048. Okay, and then I just punch that into my calculator, and that should give me a height of 2,304. Okay, that's my height. So that's the maximum height of my projectile. So that's way up here. So now we just got to figure out how long it takes till it hits the ground. Well, if we start it at the ground and shoot it up and it comes back down and it hits the ground, well, what the ground really kind of is, as far as a graph is concerned, is the x-axis. In other words, I got to figure out when this thing gets back down to 0. Okay, and so I do that by setting it equal to 0 and solving. In other words, I got to go back and use some of my strategies that we had for solving equations, like this one, negative 16t squared plus 128t plus 2048. When is that equal to 0? Well, there's going to be two answers. We're going to have the leftmost one and the rightmost one. It depends on if you shot it left to right or right to left. But anyway, we'll get two answers here, like we do every time we solve a quadratic. And we're hoping we can reduce all of these by dividing everything by a common number. And that does help us if we divide everything by 16. And that'll rewrite my equation to be negative t squared plus 8t plus 128 equals 0. And then we're really lucky because this one factors. If it didn't factor, we would have to use quadratic formula. So we put the negative 128 on top because you're supposed to multiply your first number times your 128. Put the 8 on the bottom. And then what multiplies to be 128 and then adds to be 8 is going to be a positive 16 and a negative 8. Okay? And then if you use the magic x, you can divide both of these by negative t and then reduce if possible. This, the one on the right does. So we should get t plus 8 and then negative t plus 16 equals 0. So my two answers are going to be, we got t equals negative 8, and then we're going to get t equals positive 16 if you solve. So it's going to hit the ground probably at the 16-second marker. Now, looking at the information, it's kind of an odd equation probably to have been given in the first place, to fit this situation, because what it's saying is you shot the rocket off at -8. Well, actually, probably what it means is that the picture, you were standing about right there, and so where it would touch the ground, we're assuming that we're actually started and shot it above the ground because we're holding it on our shoulder, shooting it up, something like that. Anyway, so it hits the ground again at 16 seconds. The other place it hit was over here at -8, but that doesn't make sense for time, so we're saying 16 would be our final answer here.